Hi everyone. In this video, we are going to discuss on tutorial 9 on the subtopic friction. So this is the question. The figure shows a system which is in equilibrium. So the block of mass 5 kg on the table is about to slide. So draw a vector diagram to represent the equilibrium of point O. And then use your vector diagram to find the magnitude of the forces along the string OP and OQ. Calculate the coefficient of static friction between the 5 kg mass and the table. Okay, so for question A, we draw a vector diagram. Okay, first step, we determine all the forces that act on the at point O. So we have tension in the string. Okay, then the string OP. We have frictional force. Okay, by object 5 kg with the table, and we have weight by the object 0.5 kg. Okay, so next step, we are going to draw the vector diagram. So from this T, we transfer to the vector diagram here, and followed by the angle is 30 degrees from horizontal. So followed by the weight, okay, then followed by the friction, okay, frictional force. So it form a triangle because there are altogether 3 forces. Okay, so this is the vector diagram, and all the system is in equilibrium. So if you see the arrow here, okay, it follow one after another. Right? Okay, so now we do the third step to determine the weight. So to determine the weight, we can use 0.5 here times 9.81, so 4.9 Newton. So the weight value here is 4.9 Newton. So then we can use trigonometric ratio, okay, to find the tension. So from this is right angle triangle. So sine 30 degrees equals to the opposite, which is weight, and over hypotenuse. So hypotenuse is T, tension in the string OP. Okay, so we get T equals to weight over sine 30 degrees. So substitute this weight into here, and we get tension in the string 9.81 Newton. Okay, so that's the answer for tension in the string. Okay, next, the component T. Okay, there are 2 components. We have T cos 30 degrees and T sin 30 degrees. Okay, the component of tension T. Then because the system is in equilibrium, so that is mean frictional force is equals to T cos 30 degrees. Okay, frictional force is equals to the T cos 30 degrees. And we can solve for friction. So the T 9.81 substitute into here, then times cos 30. So the answer for frictional force is 8.50 Newton. Okay. Okay, all the forces now we have calculated already. So T done, friction done, then weight also done. Okay, so now we go to find the mu. The mu is given. The friction is 8.5, so we can find the mu, and then to find the coefficient of static friction, so the mu here, so we use friction equals to mu r. So this mu is the static coefficient. So mu s, and r is equals to mg for this block. Okay, for this block. So the reaction force upward is equals to the weight of this block. Okay, so it's equals to the 8.5. Okay, next we substitute the mass of the block Q, which is 5 kg. Then the G value 9.81. So we bring to the right side. Okay, so I didn't solve for this one. So you can solve on your own lah to find the coefficient of static friction. So the M of the block Q is 5 kg and then the G is 9.81. So you calculate for mu. Okay, this one you find your answer by yourself. Okay, now we go to question 2. Okay, for question 2, a cube A of mass 3 kg is placed on a plane B. Okay, this is a plane B, which is then slowly tilted until the cube starts to move from the rest. So this occurs when the angle of inclination is 25 degrees. So what is the coefficient of static friction between the cube and the plane B? Okay, so this is the cube A and the plane B. So we are going to find the coefficient of static friction. So question B, if the cube moves through a distance of 4 meter along the inclined plane in 2 seconds, so find the kinetic friction and the coefficient of kinetic friction between the cube and the plane B. So we do question A first. Okay, so we choose the Cartesian plane, okay, x-axis along the inclined plane B, and then this is the y-axis perpendicular to the inclined plane. Okay, so now the forces that act on cube A is mg, weight of the cube A, and then we have frictional force, okay, in this direction, upward direction, because the cube move downward from the rest. So friction will be opposite, is upward. Okay, then the reaction force by the plane B, which is R. Okay, so the angle theta here is equals to the angle here. Okay, next we resolve the component of mg. So the component will be mg sin theta and mg cos theta. So this is component of mg. So for the object to start to move from rest, okay, so this is the maximum static friction, okay, maximum static friction. So we use limiting static friction, so which is equals to the mg sin theta. So Fr is the limiting static friction, so equals to mg sin theta. So from the R here and mg cos theta, so they are also equal. R equals to mg cos theta because the block doesn't fly, and also the block does and the plane here doesn't collapse. So that's mean it remain moving on the along the plane here. So they are equals, R and mg cos theta. So this is equation 1 and equation 2. So we use ratio. Fr over R equals to mg sin theta over mg cos theta. So sin over cos is tangent, so tangent theta, and Fr is mu sr because this is limiting static friction. So it is equals to mu sr then divided by R. Okay, mg can be cancelled out. So from here, R also cancel out. So we can calculate coefficient of static friction that has been asked by the question A here. So mu s is tangent 25 degrees. So the angle given 25 degrees. So you get mu s 0.47. So this is the answer for A. Okay, next we do question B. So if the cube moves through a distance of 4.0 meter along the inclined plane in 2 seconds, so find the kinetic friction. Okay, this time is the cube is in motion, so the friction involved is the kinetic friction. Okay, and the coefficient of kinetic friction mu k. We name this as mu k. Okay, so now for question B, the object, the cube is in motion now, so that's mean it has we use Newton's law, F equals to ma. So F is the resultant force, so the object now accelerate downward. Okay, so mg sin theta minus Fr because it moved downward, so mg sin theta is positive, minus Fr because opposite direction. Okay, so this is first equation. Second equation, R is still equals to the mg cos theta. Okay, from these two equation, we need to find A, the acceleration. So from the given information here, distance travel 4 meter and the time taken 2 seconds. So we can find acceleration from this information given. Okay, so we can use S equals to UT plus half AT squared from the linear equation. So we choose this equation. So we substitute the 4 meter displacement, and then at initial from rest, the U is 0, and then plus half A, that A is what we are going to find, and then time taken is 2 seconds. So we can solve for acceleration, we get 2.0 meter per second per second. So you can substitute into this equation. So we get mg sine theta minus fr is mu kr and equals to acceleration is 2, so 2m, 2m. So this is equation 1. Okay, so now from these two equation, we solve the mu k using simultaneous equation. So we substitute the equation 2 into 1, okay. Then we get mg sine theta minus mu k. So r is mg cos theta equals to 2m. So from this equation, we can cancel out m. So we get g sine theta minus mu k, g cos theta equals to 2. Then we rearrange the equation to get mu k. So we get, from here we get g sine theta minus 2. So we bring 2 to this side. So minus 2. Then divided by g cos theta. So g cos theta bring down, become g cos theta. Okay, so now we substitute all the values given. G is 9.81, angle is sine 25 degrees minus 2, G 9.81 cos 25 degrees. So you get mu K 0.24. So this is the answer, 0.24. Okay. And the kinetic friction, okay, I didn't do here, but you can substitute into this value, mu kr, so you get friction. So the kinetic friction, this is kinetic friction, Fr. So you substitute the 0.24 times the R is mg cos 25 degrees. So m is 3 kg and then g is 9.81. So you can get kinetic friction. So I didn't do here, so you can do on your own. Okay, so this is question 2, and then we go to question 3. So a block A of mass 3 kg, so block A is 3 kg, is connected to another block B of mass 2 kg by an inextensible string. The blocks are pulled by a force F, which is increased until the blocks start to move on the horizontal surface. Okay, so that's mean static friction, limiting static friction involved here. So this F equals to 20 Newton is equals to the limiting static friction, because the F is pulled, the F is increased until the blocks start to move. Okay, now this occurs at this F equals to 20 Newton. So it is understood that F is the limiting static friction. So we can find the question A, limiting static friction between block A and the surface. And then the second question, limiting static friction between block B and the surface. And then we calculate the tension in the string connecting A and B, the tension in this string. Okay, so we do A first. So let's say the frictional force by A is Fa and by B is Fb. Okay, so these two forces is frictional force. So we use limiting static friction formula mu SR, and R is equals to the mg, the weight of the block. Okay, the weight of the block. So block A and block B. So this is the formula. So now we substitute for frictional limiting static friction. Fa equals to mu S, and then times the mass is 3 kg for block A and then G. So for B also we do the same. Fb equals to mu S, the mass is 2.0 kg, and then times G. Here the formula mu S mg. Okay, then the total frictional force here, Fa plus Fb is equals to 20 Newton. So this two is the limiting static friction. So the total of this force is equals to 20 Newton. So why they are equals? Again, I repeat, because this force, this 20 Newton, is increased until reach 20 Newton, and the block start to move on the horizontal surface here. Okay, so now we have three equations, so we use simultaneous equation to solve for FA and FB. Okay, so the first two equation we use ratio, so FA over AB, so mu S we cancel out. Mu S is the same because the block is the same type, and we assume the block is the same type and the same surface. Okay, so therefore the mu S will be the same. So G also cancel out. So we get 3 over 2, and cross multiply, we get FA equals to 1.5 FB. And then we substitute this into here, into FA here. So 1.5 FB plus FB equals to 20 Newton. And we solve FB, we get 8 Newton. Okay. And then for FA, we substitute FB into here. So 1.5 times 8. We substitute into here. So we get FA, limiting static friction, for block A is 12 Newton. So we answered the question 1 and 2 already. Okay, so now we go to question B. Question B, we are going to determine tension in the string connecting AB. So for tension in the string, so the direction that this string will form action-reaction force by B on A and A on B. So this is action-reaction force. So if you use block A to calculate the T, so that means the T is equals to FA. Okay, T equals to FA. So FA calculated already, we get 12 Newton. So tension in the string is 12 Newton. Or another method, you can use block B. Okay, so for block B, is T plus FB equals to 20 Newton. T plus FB equals to 20 Newton. So you still get the same answer. So FB is 8 Newton. So you bring to the right side, 20 minus 8, 12 Newton. So which method you want, which equation you want to choose is up to you. For block A or block B. So you use the separate body, separate body methods. Okay, so now we do question 4. Okay, question 4, we read the question. What type of friction, static or kinetic, acts between the tires of a car and the road when the tires are rolling or when the car skids across the road? So we do question A first. So the tires are rolling, okay, like this animation. So it's rolling. So every time it rolls, the two surfaces in contact will change. Will change. Okay, so it is as if it's a static friction. So the new each time the new contact for the surface. So that's mean the type of friction involved is static friction. No sliding of one surface okay. If you see when each time it rolls, okay, so no sliding. Then the tire, no sliding of one surface of the tire with the surface of the road, because each time it rolls, so the new surface between the in contact between the tire and the road. In this example is the road lah. Okay, so now we go to the second question. When the car skids across the road. Okay, so when the car skids across the road, the car skids. So that's mean it drags. You see, you can see from the animation here. Okay, so you can see the tire. It's when you apply the brake, so the tire doesn't stay stationary, so it skids. This is what it's meant by skid. The car skids across the road. Okay, so what involved is kinetic friction. So the object is the tire now moving, moving, and each time only the part of the tire still slide over the surface of the road. Okay, so some part of the tire slide over the surface of the road. Okay, so like this below here also got animation, so it doesn't rolling, so it stay the surface between the two. I repeat the animation, so you see the surface between the two remain the same, eh? And the object is moved, so there is a friction between them. So this kind of friction is a kinetic friction. Okay, so now we go to question 5. Okay, question 5. We read the question. The coefficient of kinetic friction between the tires of a car and the road is 0.40. So this is mu. Okay, then in an accident, the length of the skid mark of a vehicle is 52 meter. So from the animation, you can see here when a brake is applied. This is the skidded mark, the skidded mark on the road. So what was the speed of the vehicle before it skidded? So at initial here, this is before skidded at initial when it start to skid. Okay, so we are going to find the speed at this point. Okay. So now this is another diagram. So this is the skid mark. The skid mark. So starting from here is u that we are going to find initial speed. So the distance travel is 52 meter, and the mu k is given 0.40. Because this is kinetic friction, so the coefficient is the coefficient of kinetic friction, 0.40. So at final, the final speed is 0 because after sometimes it stop, the car stop. Okay, so the v is 0. Okay, so from here we can use linear equation. Okay, linear equation, we choose v squared equals to u squared plus 2as. Okay, so but we don't know a, so we need to find a. To find a, you can use f equals to ma. Okay, so we can find the a. So f equals to ma. So the f here is the resultant force involved here is only what do you call this? Friction force. So the frictional force. So f is the frictional force. So the resultant force is frictional force, and it's opposite in direction. So minus mu r. Okay, minus mu r. So the motion is if in this diagram, so the motion is forward, and then the frictional force is backward. So that's why it's negative. Okay. If from side view, so the motion is this way to the left, and then the frictional force is opposite. So that's why minus mu r. Okay, so R is mg. So this is weight of the car. Weight of the car. So R is reaction force is equals to the mg because the car doesn't fly. The car doesn't fly. So it remain move horizontal. So that's mean R equals to mg. Okay, so now we cancel m and we can calculate a equals to negative mu g. Okay, so you substitute into here negative mu g. So v squared equals to u squared minus 2 mu g s. Plus minus become minus, and now we substitute all the values. So v is 0, u is the questions ones, 2 minus 2, 0.4 mu, g is 9.81, and distance travel is 52. So you solve, you get u equals to square root of 2 times 0.4 times 9.81 times 52. So you get u is 20 meter per second. So this is the initial speed of the car, 20 meter per second. So that's the answer for question 5. Okay, so that's all for tutorial, this tutorial 9, and bye bye.